Okay, we're going to review our answers for number 11. Remember, we're taking our test on this in just a few minutes. This was our review for our test. The first section of the test is where we're going to need to draw the tiles because we're testing a state objective that you can use a physical model to perform indicated operations. So 2x squares, we're going to have to draw them first, number 1. Next thing we have is plus 3, so we draw 3 ones. Next we draw 2 x's. Then we're asked to draw an x squared. And last we're asked to draw 2. Then we're going to put them together. So I can see I have 1, 2, 3 x squares. I have 1, 2 x's. And last I have 1, 2, 3, 4, 5 constants. Okay. Again, we can double check by looking at our like terms. 2x squares plus an x squared gives us our 3x squares. 2 x's, nothing to go together with them, gives us our 2 x's. And last, plus 2 and plus 3 go together to give us our plus 5. Problem number 2. This time we have to draw y's and x's. We want to be real careful when we draw a y that we make it a lot longer than what we're going to draw for our x. Remember, x's are a lot shorter than y's. There's our 2 x's. The 5 piece is a little longer than an x piece, a lot shorter than a y piece, and split into 5. Then I'm going to draw 3 more x's. And last, I'm going to draw 2 negative y's. So again, these long ones. And a negative sign in them. Those are my negative y's. As I combine my like terms, I should see that I have 0 pairs with the y. 1 positive y and 1 negative y make a 0 pair. I'm left with a negative y. And then I count here, I have 1, 2, 3, 4, 5 x's. And last, I have 5 constants. 1, 2, 3, 4, 5. Plus 5. Number 3, I want to draw 4 x's. 1, 2, 3, 4 x's. Then I want to draw 3 negatives. 1, 2, 3 negatives. Then a positive x squared. Then 5 positives. And then 5 negative x's. 1, 2, 3, 4, 5. Or I could have just drawn a 5 piece. Now I look to cancel out my 0 pairs. So 3 negatives cancel out with 3 positives. And in my x's, 4 positives cancel out with 4 negatives. And then we look at writing down what's left over. So I have an x squared. And then I look at my x's. I'm left with 1 negative x minus x. And last, I'm left with 2 positives plus 2. Again, doing it the way would be if we were showing a work. You can see that should be an x squared. Put together our 5 negative x's with 4 positive x's. That leaves me with 1 negative x. And then last, negative 3 together with positive 5. We can see that the constant is 1 by 2. Up here, we're going to have to write and then evaluate the expression. So again, we want to write this in simplest form. You see we have an x squared. I have plus 6x. And I have plus 6. So that needs to be the first thing on all of my lines, my expression. X squared plus 6x plus 6. That expression is 63, 6 threes, which is 6 times 3, plus 6. Following order of operations, 3 made into a square is 9, 6 threes is 18, and 6, 9, 18 is 27, and 6 more is 33. In this case, we're going to want to replace our x's with 7, so that x becomes 7. The square is still next to it, the plus the 6. X gets replaced with 7. Again, remember that should be 6 times 7, or 6 sevens, not 67. Plus 6. 7 squared is 49. Plus, we got 6 times 7, which is 42, plus 6. So then we can add those together. You will have a calculator on your test. So you're adding together 49 plus 42 plus 6, and that comes out to a total of 97. Last, we're going to replace our x with 1.4. Nice thing is, since you have a calculator, nothing changes here. 1.4 goes in place of our x. Square is next to it, plus 6. 1.4s. Again, remember it's multiplication. And last, we have plus 6. So 1.4 squared, using your calculator for that, gives you 1.96. Plus, then we have 6 times 1.4, which gives us 8.4, and plus 6. So we have 8.4 plus 1.96 plus 6, and my calculator tells me 16.36. Okay? Again, you may have y's in there, and that'll tell you how much the x is worth and how much the y is worth, or maybe they'll just have y's and tell you how much the y is worth. Whatever the case is, you replace the variable with that amount, substitution, and then you follow your order of operations. Last one, we're adding and subtracting polynomials. Remember, we're always going to write a second line, so this is going to be y squared minus 3y plus 2. The first set of numbers always stays the same. This positive tells us that our next set of numbers is going to stay the same. So this is a plus 3y. We're going to write plus 3y squared. Sorry, plus 3y squared. Next we have minus 4. So we're going to write minus 4y's. And last we have minus 5. And now we're ready to combine our like terms. Remember, we're including the sign out in front. Y squares go together with y squares. That gives me 4y squares. Then we have minus 3y together with minus 4y. No zero pairs there. There's a whole bunch of negatives. 7 of them all together. And that's my y's. And last, we're putting together our positive 2 with our negative 5. And here we end up with minus 3. Okay. Number 9. Again, nothing changes to start. 3x squared minus 5x plus 6 gets written down. This negative tells us we're going to have to change all of the signs. So the first sign in here is a negative on the x squared. We're going to change it to a positive x squared. Please note, this negative sign didn't come down. Okay, what actually is happening is it's getting distributed to all 3 terms. Okay, so whatever the sign is, it becomes the opposite. Okay, when the sign is negative, it becomes positive. Up here, when the sign was positive, it stayed positive because it was a plus. If the sign was positive, it'll become a negative when you're subtracting. So the next one is going to become negative. It was plus 2x, so it's going to become minus 2x. And last, it was minus 6, so it's going to become plus 6. When you're subtracting, okay, you're changing all of the signs that follow, and that's using distributive property. So we're going to put together our 3x squared with our x squared, and that is 4x squared. Next, we're going to put together minus 5x That gives us minus 7x's. Last, I'm putting together my plus 6 with my plus 6, and that gives us plus 12. Again, please note how I'm being careful to include the sign on the term. Last problem, number 10. Remember, first set of parentheses, we're not changing anything because there's really a plus out in front of it. Plus 4b squared minus 3b. This negative tells us we're going to have to change all of the signs that follow it. So this positive b squared becomes minus b squared. The positive 2b becomes minus 2b. And the negative 6 becomes positive 6. Okay. Again, to point out, this negative sign isn't being brought down, it's being distributed, and we're writing the opposites of the signs on each term when you're subtracting. Now we're ready to combine like terms. So I have 5b cubes. No other cubes in there. Next I look for b squares. I see I have 4b squares, and here I have minus a b squared, so that's going to bring me down to plus 3b squares. Next I look to my b's. I have minus 3b, and I'm going to put that together with minus 2b. Minus 3 and minus 2 is minus 5b, no zero pairs there. And last, I have plus 6. So this is what your work needs to look like. I need to see that you've rewritten it without parentheses. When it's addition, you just copy everything exactly the way it is. All the signs in here stay the same. When it's subtraction, you're changing all of the signs as you copy it to your second line. Then you're combining your like terms. Good luck on your test.